Okay, so my name is Richard Boyd. I'm a developer advocate for AWS developer tools. There's another Richard Boyd who works for AWS who focuses on DevOps. He's a solutions architect. So I always make sure I put my middle initial on there. I'm not trying to be like pretentious or anything. It's just the only way we've decided to disambiguate between the two of us is I use my middle initial and he goes by Rich. That's the truce we've established because people will send me stuff meant for him and send him stuff meant for me. Only one time someone like yelled at me thinking that I like he signed them up for something or didn't sign them up for something. And he said they would, and they yelled at me. And I'm like, normally I'm nice and I forward these, but you're being rude to me, so I'm just gonna delete it. I can't imagine the number of times he's gotten yelled at because I'm a lot less polite than he is, because I delete random emails. But yeah, so I'm Richard Boyd, I cover developer tools. This includes our entire code suite services. So this is things like the AWS code build, code artifact, code commit, all the DevOps tools people use, tools developers use kind of every day. That includes our SDKs and tools, so that you can interact with AWS in your programming language of choice. Our IDEs and toolkits, so if you want to use VS Code, IntelliJ, any of the JetBrains IDEs, Eclipse, we have toolkits that integrate with those IDEs that have the ability to interact with AWS, so you don't have to leave your IDE. We also offer our own cloud-based, like web-based IDE. Runs in a browser on the EC2 instance in the cloud, so you don't have to worry about transferring large amounts of data. If you're on a plane, you can build a 600 meg Docker image in a few seconds because it's all in the data center. And it's just pushing the image of it to you. It's basically an SSH connection. There's probably something else I'm missing. Someone's yell at me if I don't mention it. We picked up a lot of the Rust programming language, like the Rust platform team has joined AWS after Mozilla disbanded it. So I do cover that a little bit. They do a lot of their own developer advocacy and outreach, so I just support them as needed, but it's primarily code suite, IDEs and tools, and our SDKs and toolkits. One of those tools is, one of those toolkits is what's called the Cloud Developer Kit. Just as like a show of hands, like who considers himself like a beginner on AWS? Intermediate? Expert? Super expert? Yeah, I know I have like 4 or 5 categories, right? Okay, so Cloud Developer Kit allows you to like build and provision your infrastructure programmatically. It's this idea of what's called infrastructure as code. It's a tool that's built on top of another service that offers this, but for people who are new to AWS, they may not have been exposed to those services before, so I'm going to introduce those. So this might be kind of boring for you or a recap. I'm sorry, that's what happens when you're late. So we go through like the history of how people build infrastructure. I'm going to skip like everything before the cloud. Right? I'm not going to talk about how hard it was to lease space in a data center and find someone who will sell you physical Dell servers, and you have to actually rack them, connect them to power. We all know that was hard. It's not relevant to this, so I'm just going to pretend like the world started when the cloud started. Right? And the way people would, sorry, next slide, one more time. Thank you, sorry. I said I was going to tell you next slide.
That's okay, we'll figure it out.
So the way it started was it was very manual, right? Someone would log into the console and they would click around and they would create some resources. I use S3 buckets as a common example because everybody knows what those are. DynamoDB tables, Lambda functions. Lambda functions is kind of not really true because it came about much later. So in the very early days, no one was doing that, but people still do this manual provisioning today. And if you had the one person on your team who knew how to do this, they were good at it, and they would write down what they did in case they get hit by a bus or they get sick or they leave the company and they don't want to ruin everyone's weekend. They'll write this down. It's on wikis or playbooks, or this is here, ask Bob, he knows. And the difficulty of this is that it's really hard to automate, right? Like we have tools like Selenium and WebDriver things that'll do this, but it's really janky, right? You have to like understand like XPath and like CSS and all this other like weird web front end stuff that nobody really understands. And someone changes the console and all of your automation breaks. It's not a good approach. Next slide. So people wrote bash scripts, right? So that you can, underneath the hood, what the console is doing is it's making an API call to an AWS service. And it's just kind of showing it to you graphically so you know what's going on. If the console is making a HTTP call, there's no reason why I can't from Bash or Python or JavaScript or whatever my language is. So people put together these huge bash scripts. The challenge with these was that if there was a mistake, let's say you're running this bash script on your laptop and the internet cuts out for just a minute and the request fails. How do you restart that script in a normal spot, right? If you start it all over again, you may have been in the middle of provisioning something. You're gonna restart your order to provision 2,000 instances. Like, what are you gonna do with the other ones? They're just gonna be these orphan resources that only show up at the end of the month in your bill. So, or if you would encounter an error, you're trying to deploy something and you realize there's a bug in your script and you either have to cancel it or you want to undo it. Like, how do you roll that back? And you end up having to invest a lot of money and resources into making these bash scripts like very robust to handle failure, recovering from failures, failing gracefully, rolling back. This, it brings its own set of problems. So it solves the automation problem, but it brings its own. So the next step is something like CloudFormation or Terraform. And these are infrastructure provisioning engines. Oh, sorry, next slide. So these are infrastructure provisioning engines. And what they do is they handle everything I described about gracefully handling a failure, rolling back the changes, deciding should I roll everything back? Should I just stop right here? Should I retry some number of times? And the idea is that you would give these provisioning engines this like declarative description of your infrastructure. And that's basically just saying, I want a bucket, I want to have this property, I want to have this property, I want to have this property, I want a function with these properties. They say it's declarative, it's just like a list. Like here's a description of the state. The alternative to that, some people you'll hear talk about imperative. That's more like a recipe. It's like create the bucket, add this property, add this other property. One of the downsides of hearing that is that implies that the order in which you add those properties matters. If you add property A, add property B, could you add property B first and not A? You end up having to develop like a deeper expertise to understand like if you can do that in those orders. If you've used Java before, you talk about like the Java builder pattern, it's very similar. With declarative, you can just say, here is basically a map. This is where I want my building to look like, and it'll build the building for you to understand where they need to be done in. The downside of that is that because they're declarative, they have to be very verbose, right? If you've seen floor plans for buildings, it's usually not a single floor plan, it's hundreds of them because it's your floor plan for your electrical grid, floor plan for water, for, I hope the sewers part of the water is separate from the drinking part of the water. I don't know enough about buildings, but all these different layers and like complexity to this, these declarative descriptions of infrastructure they're very verbose, they get very big. So we want some of the benefits of the next one. Some of the benefits of like that declarative, very clear, unambiguous description of our infrastructure, but with some of the benefits of imperative code. I want a loop. I want something that's going to generate this. I want 10,000 buckets. I don't want to say make bucket 1, make bucket 2, make bucket 3. I want something like make 1,000 buckets, put it in a for loop or a while loop or something like that. Sorry. He tried to get ahead of me. So every time I looked at the screen, I was about to press it. Sorry. Now I just distracted myself. So you end up with these things like troposphere and GeoFormation. They're very popular for a few years. Some people still use troposphere, but they've mostly been replaced by abstractions. These abstractions are things like AWS CDK, the Cloud Developer Kit, and Polity. What these do is these allow you to take an idea of some like collection of cloud services and bundle them together into an abstraction. So instead of just saying like, here's an S3 bucket and an API gateway API, a Lambda function, and maybe a Route 53 entry as like separate things, you could bundle all those together with specific properties and say, this is a static website. If someone wants a static website, they just get a static website. They don't have to think about the underlying components that are needed to make that work. And it gives them a lot of these either things that need to be configured a very specific way already configured, or like best practices already baked into there. Next slide. So the Cloud Developer Kit is our tool for providing these abstractions. Just quick show of hands, who has used CloudFormation before, AWS CloudFormation before? Okay, I just realized I had assumed everybody had, or so CloudFormation is when people talk about CloudFormation, they could be talking about one of several things. So I just want to make sure I'm clear about it. So there's CloudFormation service, which is a service that runs in the cloud, and it accepts a CloudFormation template, which is just a JSON or a YAML file that describes your infrastructure. And you just give your template to that service and say, make my infrastructure. And it is the provisioning engine that'll go off and build your infrastructure. Sometimes people will use CloudFormation to refer to the templates itself. They say, oh, I build my infrastructure on CloudFormation, meaning they write the CloudFormation templates themselves and then give it to CloudFormation service. What CDK does, oh, yes, we talked a moment. What CDK does is it writes that CloudFormation template for you. So it authors that for you. That's the big declarative, unambiguous description of your infrastructure. And we expose that to you in a programming language that you might already be familiar with. So you don't have to learn the domain-specific language that CloudFormation uses. Or we have a new server, there's a new support for CloudFormation for Terraform called CDK-TF. They have their own domain-specific language that they call HCL, the HashiCorp config language. It's a YAML document that has some schema associated with it. And we have roughly the same capabilities. So in this talk, I'll talk about the AWS CDK, but much of the things I talk about, the abstractions and reusability, apply to both. We call AWS CDK for CloudFormation and the Terraform HCL configuration. And like I said, it exposes this infrastructure definition in a language that you're familiar with. So Python, JavaScript, TypeScript, Java, C#. Go is in preview right now. We expect it to GA, something like it could be generally available in the API be stable around the end of the year. I'm hoping, fingers crossed. We're trying to drive more adoption to it to make sure that enough people have used it and tried it and really like fleshed out a lot of the rough edges on the API before we say, okay, now we'll never have another backwards compatible change without a major version bump. Again, it supports abstractions and tool support. If you're writing your infrastructure in something like Java, you can use JUnit to test it. If you're writing a Python, you can use PyTest. If you're writing it in CloudFormation, which is YAML, if you're writing it in HCL, you have to either write your own kind of YAML schema parser or use an existing off-the-shelf one, and it loses a lot of context about what it's trying to do. You end up having to build a lot of very low-level tools to test to make sure that your template is configured or perhaps appropriately. Oh, and I forgot to mention, if anyone has any questions, feel free to interrupt anytime. I don't want anyone to have to wait till the end with their question, and then by the end they've been thinking about their question so hard they didn't pay attention and they're really confused. So any questions, feel free to interrupt. So the main components of CDK, just like I said, CloudFormation is several things depending on who you ask. CDK is very similar. So there's like the core framework of CDK, which is we call apps, applications, and then stack. Stack you can think of like a CloudFormation stack. It's you give CloudFormation a template, it will create a stack from that, which is a resource inside the CloudFormation service. We have a notion of a stack inside CDK, which more or less corresponds to the same thing. There are very subtle differences, but at introductory level, they don't really matter. And then the stacks contain multiple of these like AWS resources. So I think that's Shield or WAF. If anyone's taking these certification exams, they probably know these. I'm not sure if they test on those or not. Lambda and S3 are the other two that they just show that they contain some resources. But the main components, the core framework are these are the core bits of CDK that kind of hold all stuff together, and they do the actual translation of the Python code to TypeScript, the Java, or Python code to TypeScript, TypeScript to CloudFormation, or Java to TypeScript, TypeScript to CloudFormation. TypeScript's always at intermediate level because of the way it works with its language translation. We write it one time in TypeScript, and there's a tool that we have that makes the language bindings available in all these other languages. So we don't have to worry about maintaining 7 or 8 different copies of it. We write it once. We have this tool that then programmatically generates the language hooks. So you get instant support across all these languages. And that tool is also open source, so anyone can use that. There's a guy who made a calendar that's the new calendar is not the same as the Gregorian calendar. Is that what we use? The Gregorian. There's a calendar that we use in America. I think the official US calendar, I think it's called the Gregorian calendar. There's probably someone in chat. I guess I bored him, I guess. I'm just kidding. And so there's a different calendar. Some of these like lunar calendars are different types of calendars. There's a point to all this, I promise. And the idea is that he wanted to write a tool that would translate like today's date to one of these like Hindu calendars. And he wrote it in TypeScript. But he also wanted to make this tool available to people who are using Java or people who are using C# or Python. And he didn't want to have to write 6 of these. So this tool called JSII, the JavaScript interface interrupt. I forget what it actually means, what the acronym stands for, but the idea is that creates these language bindings for you. So you can write something once in TypeScript and then make it available to people using any of the supported languages. So you basically get free language support. That's what CDK is built on, but that capability isn't unique to CDK. We make that open source. People can use it for whatever. We just happen to use it for infrastructure provisioning. That was a very long detour for no reason. I apologize. I mentioned this is my first in-person live talk since pandemic started 18 months ago. So I got 18 months worth of talking to get out. The next part is the construct library. So each of these core bits inside of here for the resources is a construct, we call it. We'll go into a little bit more detail about what a construct actually is and the different types of constructs, but you can generally think of a construct library as being a collection of constructs that correspond to an AWS service. So there's one library per AWS service. So here there's, I'm not sure, the screen is very small and that one's very far away, and neither one of them are great. Yeah, so that's showing, looks like some container-based stuff. We have some serverless API gateway is in the middle, Lambda on the left, DynamoDB. Each of those is a collection of constructs associated with it. API gateway will have your REST API, HTTP API, and the WebSocket API that offers containers. You'll have ECR, there'll be one for ECS, et cetera. I can list off. So, and then finally, there's the CLI. It's the thing that runs on your machine that helps you interact with both the construct library and the core framework. And I'll walk through an example of this. It's theoretical. I'm talking very fast. I'm not making a lot of sense. We'll go through some demos and hopefully become clear, or become more confusing, and I'll look a lot smarter. And this is just an example of a CDK application that builds a application load balance Fargate service. So it's creating a Fargate service, which is a task that you run on demand, very similar to the Lambda function, but it's inside a container. And then it's using an application load balancer, an ALB on the front of it to manage it. So typically, in order to do that, you would have to define the actual task definition of what image you wanted to use for your container image. We have to specify what kind of ALB you wanted, what ports you wanted it to listen to, a bunch of networking stuff, maybe some security groups for inbound, outbound access. But what we do is well, most people if you have a web application, you probably want it on port 80. So let's just set port 80 as the default and give people the ability to overwrite that if they want to. Or they probably, if it's TLS, it's secure, they probably want to run it on port 443. So let's do that also, or give them a flag that they can very easily set that. Then we create a VPC and the ECS cluster. Yeah. Quickly look at the development flow looks like. Someone on the CLI on their machine will run CDK init, and this will initialize a sample application or a library. There's an option I'll show when I do the demo of what that generates. It creates a new project. And then for this one, they're using NPM. So they'll run NPM run build, which will build it. And then we'll build their application. So NPM's in a weird spot. If you use TypeScript, TypeScript compiles down to JavaScript. Java compiles down to, what's the name of that bytecode that JavaScript turns into? JavaScript has to be compiled. That's the crux of that. C# is very similar. Python doesn't need to be compiled. JavaScript doesn't need to be compiled. Those are interpreted languages. So you wouldn't need the equivalent of an npm run build command if you were using one of the other supported languages. Just for this demo, it looks like someone is using TypeScript for some reason. Trying that you have to manually build that. And then once it's built, you run CDK synth, which synthesizes your template. And that's what actually generates the CloudFormation template. I say generates, there's a small star on that. It generates a type of template. It generates template, but it's not guaranteed to be fully complete because there's some things that might only be able to get at deploy time. But then what CDK synth allows you to do is to look at what it would have deployed had you actually tried doing the deployment, so you can test it or validate it or do some kind of checks against it. Because there are times where you'd say, create an S3 bucket. I don't care what you name it whatever you want. And then on this other thing, use that bucket's name to set an IAM permission so that some role is only allowed to read and write from that bucket. Your IAM role needs to reference the bucket that was created, but it might not know the bucket's name until after the bucket's actually created during deployment time. What CDK does inside CDK, when you do CDK synth, it puts a token in there that it'll replace later when it has this information available to it. all this to say is that, I mean, you don't have to, I'll just check more, okay. All this to say is that CDK synthesis should be treated more like a branch off of this workflow, as opposed to like a step you have to go through. You can go through the workflow and not do a synth. Synth is just like doing like print statements here. I know we all use the actual debugger in our IDEs, right, and step through stuff and look at variables exactly how we're supposed to. Nobody here uses print statements to look at the value of a variable while they're trying to debug something. I certainly don't do that. But CDK synth is the cloud equivalent of doing that. It's a very simple way to see, okay, sanity check, am I on the right path? And then you can do a diff, so you can say, okay, here's what this thing would have produced if I tried to deploy it and I already had a stack deployed. Is it going to delete stuff? Is it going to create stuff? Is it all net new? Is it identical? Is there no diff? Very similar like a git diff operation. Again, that should be like a branch off the side. And then the final step is the CDK deploy. And that takes your template and actually deploys it to the, generates it, deploys it to the CloudFormation service, and then tracks what CloudFormation is doing with it so it can tell you when it's done. So that's a very long, short introduction to the CDK workflow. I'll go through this in the demo, which will probably also be equally as confusing. Oh yeah, I forgot this part. When CloudFormation is done, it creates a bunch of cloud resources. Again, that should be like a bunch of like nodes off the tree because you very rarely have a CloudFormation template that produces one thing called resources. Usually you have a bunch of resources, buckets, IAM policies, Lambda functions, EC2 instances. Did I lose my ability? There we go. I'm gonna skip this one because it always causes fights and it's not really relevant. No, so I mean, it's the idea of like declarative versus imperative. People get into fights about object-oriented languages, declaratives, infrastructure, loops and conditions, and like tabs and spaces, right? Like people are going to fight about this. It's not important. If anyone thinks it's important, like we can fight about that instead. I think that's even better. So we'll go into these constructs. This is the thing I said, it was like very small on my screen. Now it's bigger on my screen and it's close. So each service, so AWS Lambda, API Gateway, DynamoDB, there's a construct library for each service. So you can take a dependency, say, I want to use Lambda functions in my infrastructure and pull in the library for Lambda functions. You say, I want to use Lambda S3 and load build, and you can pull in those dependencies and you can build those resources. And we describe like how much we try to help you in each of these constructs, and there's different types and levels. So what we say is, the next slide, that there's what we call L1 resources, which is for doing nothing to assist you. It's basically writing CloudFormation in another language. You have to, everything that's required in CloudFormation is required in L1 construct. Everything that's optional in a L1 construct, optional in CloudFormation. And this by itself isn't super valuable, but it bridges that gap from CloudFormation to CDK. And it's programmatically generated, which what that does, that allows us to make what we call these L2 constructs. So for the people who have used CloudFormation before, like what resources have you tried making with it? What are things you try to deploy or build? Anybody? I forgot who raised their hand, so I can't call anybody. But she's looking at you like you raised your hand.
No, I didn't. I thought we were over there.
Yeah, you are an expert, so I assume you've used CloudFormation before. What kind of resources you make? There's no wrong answer. I'm just curious. I'm going to use that as an example.
EC2s, VPCs, lambdas, right? Gateways, EMRs.
Okay.
I can continue.
Yeah, no. So VPC is like the one everyone like we always talk about. Like we always bully it, we pick on it because it's not an example, but like an EC2 instance, right? When you create the EC2 instance, you need to say what VPC you want to put it in. You need to say what subnet you want to assign to, what security group you want to assign to, and all these things are required properties, right? If you are defining these in CloudFormation, if you don't specify one of these, it'll throw an error. Say this expected property is missing, and hopefully it'll say that. Sometimes it just says there's an error, especially if it's YAML and like the white space is off, and then it's fun trying to deplete that. I can't really complain because Python does the same thing, so it's not like CDK is any better in that regard, but there's like these kind of required properties you have to specify, but for the most part, like generally don't care what specific availability zone EC2 instances. If you're just spinning up an EC2 instance real quick to test something, it doesn't matter to you if it's in US East 1A, US East 1B, 1C. You generally only care that it's in US East 1. Or sometimes I don't even care what region it is in, but the console's region based, so you put it in that region. So what the L2 constructs do is it sets default values that we think are appropriate for most customers, but it gives you the ability to override those. So you can say in just a few lines of code, say, I want a new VPC. We'll create a VPC that's got 4 or 5 subnets, 2 private, 2 subnet, 2 private, 2 public. I think there's a NAT gateway, and there's a bunch of other resources that we think your average VPC looks like without you having to specify all this stuff. And that's an L2 construct. So it's a single, more or less a single CloudFormation resource, but with all of the required properties set to some default value we think makes sense. So it makes it very easy to get started. And finally, we have the L3 constructs, which these are opinionated abstractions. It's the thing I talked about earlier when I said it's a S3 bucket, a Lambda function, API gateway, Route 53 entry, ACM certificate, all bundled together to make a static website. And that static website is the construct that's given out. So you might expose some properties on that, say, this is a static website, you just have to give it a domain name and it'll build everything for you and the infrastructure as code. Because that spans multiple services and it fulfills a very specific purpose, we call that like an L3 construct. It says L3 plus here. I've heard some people referring to like L4 constructs, but it's like title inflation. I don't think they're actually any different.
It's a little behind on the chat, but there was a question in the
yeah.
chat. Does it take CloudFormation templates as an input to convert into a project?
There is a capability now that we're working on, because this takes your CDK code and turns it into CloudFormation template. We do have a tool that you can run that'll take an existing CloudFormation template and turn it into CDK code. It's not very pretty, but it does that first heavy lift for you, and then you can refactor it from there. Hopefully that answers the question. Oh, I just realized I was supposed to go through each of these as I said. The pictures accompanying everything I just said. I'll have David share the slides once we clean out some of the materials, so it's a bit more easy to digest. This is the VPC, so it includes a load balancer, Fargate service, an ECS task, 829 lines of CloudFormation, and it's they're being tricky here because what some people will tell you is that this is technically one line because that's all one long method call that's just wrapped around, which okay, sure, but ECS patterns have to be defined somewhere, so there's an import statement they've conveniently left off. This has to be inside a CDK stack, so that's another thing that's wrapped in conveniently left off. So in a single line, that's not really true. They're probably gonna yell at me for saying that, was it the term where you narrative violation? Sorry, because I get distracted easy. And then we refer to constructs as how stable they are, right? Because we're developing this open source, we're doing a lot of work ourselves, the community's doing a lot of work. We want to give people an idea of what they can depend on being stable and what is brand new, cutting edge experimental. So there are some things that will say this is stable. The only way we'll change this is if there's a major version bump, you can follow semantic versioning, and you have a word on that. If we do make a change that breaks that, you file a bug, we roll back, we revert it, we undo it. And then the opposite of the spectrum are experimental. Use at your own risk. If you use this and it destroys a bunch of stuff, we said use at your own risk. I mean, we're not that callous about it, but there's a lot of wording saying this, the API will change. Expect to have to do a lot of work to keep up with the API, or we can't make guarantees about how stable it is because we'd rather be stable later when it's good than stable right now when it's still kind of bad and we have to support that forever. And then developer previews in the middle. That's where we think we have the right solution and we want people to validate it, that we're close. So for those, you'll probably empirically, you'll see that the API doesn't change too frequently, but we don't make any guarantees yet. And that's where we think we have the right API. One example of this was some kind of database thing where it has a maintenance window. I forget which service is related to. And there's a way you define when you want your maintenance window to be. And the way you define that is with the integer from 0 to 6 representing the day of the week, plus some other numbers representing the hour. And I want to say it was like we were off by 1, so we were using 0 as Monday to represent the maintenance window, but it was actually 0 was Sunday to represent that. So everyone thought their maintenance window was 24 hours off than what it was. And that was like a bug that we had to like go in and fix. But that came out during developer preview, so that would be a change in the API. I'm going to change that, but it's not a thing we expect during developer preview, which is why we offer that. Oh, there's that question. You can import CloudFormation templates. So we do have this, I'm trying to remember what the actually, actually it says it right there, CloudFormation include. So you can say CloudFormation include, and then you point it to where your actual template file is, and it'll pull it in and make the appropriate constructs. It's important to, does anyone use like SAM before, AWS SAM, the Service Application Model? I don't need to go into it. There's a very weird edge case where you technically have 2 different templates. There's a template you have and the template that it deploys. And those are different in some contexts. And you have to make sure you use the right one. But if you haven't used SAM before, I'm not going to confuse everybody by going into the nuances of that. And then our solutions architects have put together what they call the Solution Constructs Library, which is a collection of L3 constructs that do some small amount of thing. You can stitch these together to build applications. These are built by AWS Solutions Constructs team. So they're vetted by AWS. You can say, built by AWS. So you know that they're secure and they're safe, and if there's an issue, you can report it, we'll fix it. You get the same support that you would get from a service that had an issue, if you find an issue. And we have this open ecosystem. So there's like the CDK patterns Twitter account. I know some people don't like Twitter, but you can do it in read-only mode if you enjoy that. And it posts periodically, CDK applications that, cool patterns that they've seen show up that they turn into CDK constructs and share. And then what's this thing on the right? Sorry, I'll look at that bigger one. It might be an older one. Oh yeah, this is the product. This is our open roadmap. So there's 2 main parts of supporting CDK that we have to do. One is like creating like more and better L2 constructs. Another part is like making that CLI better, making it more intuitive, naturally understanding what you want to do with stuff. And there's this tension there. Some people want better constructs, some people want a better user experience. So we use this public roadmap to show what we're working on so people know what to expect in the future. There's also the construct hub. So there's a construct hub, which I hadn't added to here, that we just launched as a developer preview July 30th, that has those constructs that are available anytime someone's ever published a construct, publicly, we've indexed those and we keep them in a map so you can see all of those and see cool examples of things people have done. I know all this is very boring, so I'm gonna hop into a demo. Does anyone have any questions before I get into the demo?
So that, like for the L3 construct, or to have like a API gateway to land there or something, would that be set up similarly to like when you ship the L2 one, where you just have like, a constructor path and some elements and set it up that way?
Yes.
Okay.
So typically like for an L2 API gateway, I'm trying to think. So I think Lambda doesn't have any so a Lambda function, you have to define the IAM role that it needs to assume that it will operate with. And API gateway, one of its properties, like it can interact with a Lambda, you can proxy a request to a Lambda function. So separately as 2 L2 constructs, you can have an API gateway that has some routes that are exposed and just does whatever it does, right? Returns hard-coded values. Your Lambda function, you have a Lambda function that doesn't interact with anything else, it just returns some value compute. Like the calendar application could be an example of this, where it does some computation, some modular arithmetic, and returns an answer. It doesn't need to call anything else. But if you want to put those together, you need to have a policy, you need to have an IAM role that the API gateway can assume that grants it permission to invoke that Lambda function. Or you need to tell the Lambda function to put a resource policy on the Lambda function saying, hey, allow this API gateway to call you to invoke you. You have to do one of those 2 things. What the L3 does is it does that linking for you. So you just say, hey, I want to think there's actually an L3 construct in the library called a Lambda REST API, where it creates a REST API and every path, so every request, so whether it's a HTTP GET, POST, PUT, upstream, delete, on any path that you specify when you hit that API, we'll just take the whole request that you made and then just send it off to the Lambda to process it. So and it handles all the IAM connections in between there and path routing and all this stuff that you normally have to specify in CloudFormation. All that's just done for you. So that's kind of like the difference. But then you can then take that and say, okay, well, this is for that one, you create the Lambda function separately and you pass that in as a constructor property. You pass the Lambda function into the constructor property of the Lambda REST API to tell which Lambda to use. And then you can later say, grant that Lambda permission to read from a DynamoDB table. You might have a Dynamo table, you grant read, grant write, and you pass in the Lambda function to say, allow this Lambda function to read and write from this table. So you can pass around your resources as like native objects. Yeah.
You use it in the names, I'm sorry.
What's that?
You use it in the CDK code,
Yes.
by the ARN of the resource that you want to use.
You don't even need the ARN. So one thing I tell people is that if you're dealing with ARNs in your CDK code, you're still thinking in like the CloudFormation kind of mentality, right? So you'll see people try to do like string manipulation to like concatenate all this stuff together. If you're using CDK right, you would need generally, the function ARN is what you would need if you wanted to grant someone the ability to invoke the function. Creating an IAM policy, you would say, okay, well, it needs the action Lambda invoke, and then on the resource is that ARN. But what we do in CDK is that you can just say, here's my IAM policy of, grant invoke is like a method on it, and you can pass it the actual Lambda function variable itself. And then it knows that because it implements a specific interface, it knows how to pull the ARN out of that and to put it into the IAM policy. And I'll show you that with that during the demo. These are some community resources. These will be in the slides that will pass out. I'm not going to quiz you on these. Oh, so I do want to cover real quick CDK v2. Oh wait, just realized that it is. Sorry, it's extending my screen and not mirroring them. I just wanted to make it. It's one of these. There it is.
I'm sure the best way we can get everybody online to be able to see it, so, let's stop presenting. And maybe if you stand in front of the TV.
Yeah, I was just thinking like, so while I move this, I'll also talk so I can convince the owl to follow. So where I mentioned that like there's a separate construct library for each AWS service you want to use, very rarely do people ever want to use like a single AWS service by itself. Is he staring at me? Or is he-
Not quite yet.
we have to step down? Oh, you need the webcam on your,
Yeah.
okay. Then I will get out. So for the people who have used AWS, if you ever spend an afternoon on AWS and only used a single service, right, and just one service, right, you always use like multiple, right, several at the time. IAM always comes up. People joke that all AWS customers use IAM. The people who work on IAM tell you that, right, because it's how they tell people they're important. And the feedback that we got around the first version of CDK was that because you have to,
Yeah, it's just a glare. Sorry, everybody. Sure, a good way to.
you try to have it, yeah, there's one last shot. That's not me.
In the meeting, so it's trying to, it's.
Oh, I think, oh, sorry. Yeah, I still can't.
Yeah.
Share my screen.
Can you guys see the screen at all? Or is it just too much of a glare? Anybody? Yeah.
Oh, so if anyone's like kind of warm and tired, like it's about to get much worse. You know, turn off the lights or taking that.
Can you see it on your? Can you guys see that at all, or is this?
What's that?
No, the same the browser app doesn't allow you to share.
Is that what it is?
That's what you're showing.
So. It's not. Yeah, someone should. It says they can see it, but the text, they can't read it.
Yeah, maybe if you can just talk through it as best you can, we'll everybody hear what it.
We'll try this. So one of the pieces of feedback we got is that because we have people like separately declare like, I want to import this thing, I want to use Lambda, so I need to import Lambda, I want to use this other thing, I need to import it. For all these languages, like if you want to use like a Python import, you have to declare it in your requirements file, or Node.js, you need to put it in your package JSON, Java, you need to put it in your Maven POM. It's like a lot, and you have to keep track of like, oh, I thought I was gonna use Lambda, but I'm actually gonna use Fargate, so I need to remember to take out the Lambda stuff. And customer, like, it's really hard to like deal with. And then because like deep down under the hood, it is JavaScript that's actually running, that NPM isn't really good at like transitive dependencies. So if I declare dependency on version 1.7 of some package, it might pull in version 1.9 of one of its dependencies instead of 1.7. It caused a lot of pain for customers. So what we said is, okay, well, we're gonna, and then there's also the problem with some services were stable and some were marked as experimental. And we had the flags on there, but you were using it. We didn't have a way like easily inside like your IDE to say, hey, this is experimental, it's stable. It was just flags that are on the GitHub repo. I can probably open that up real quick to show an example. So we do put like build badges on or badges on the actual modules. That's not good. Right, so this one marked as stable. But you don't want to go to GitHub and say, okay, I'm taking this dependency that's stable. I think there's a certain, this one was experimental. Right. So Kim said, well, how about like just give us like all of the modules that are stable. There's just one big stable module, and all the ones that are experimental is just one big experimental module. So I know I can be absolutely certain I haven't taken dependency on anything that's not stable in my application. And that's the main focus of what we've done for CDK v2 was separate these out. So instead of having a library per AWS service, we have a library per stability. So we've got a stable module, an experimental module, and a developer preview module. Stable module is very big compared to what they were before, but it's a better developer experience because you only have to declare a dependency on one item and then it gets pulled in, and you can make some promises about what's included and what isn't included. And we've tried to limit outside of that. We've tried to limit what the breaking changes were for CDK v2. There are some things that we'd already marked as deprecated that we knew we were going to deprecate as soon as we did major version bump. We took care of that, but a lot of these have been marked as deprecated for about a year. These things kind of stuck around from the launch. So because the people in the
They said they can, it's better now, so,
okay. The box is what did it.
and the lights.
So I'm gonna limit how much I do on like the CLI, just because it can be a bit difficult. So when you run CDK and knit, you get this scaffolded application. Ignore the red build things off to the side. It's because I was using a Python virtual environment and I haven't pulled those back in yet. So this is like the demo stack that's created, and it's just creating an S3 bucket. And we see that here we're declaring that we're importing AWS S3, but we don't have to separately declare the dependency on it. in our package. So if we go into the setup.py file, we see that we have a separate dependency for the install requires. And installing this requires this separate thing. And if I were using S3 with IAM, API Gateway, all these other resources, I'd have an entry for each one of those services, and I can quickly get out of date. And the people start arguing, should they be alphabetized? Should they be arranged by how stable they are? And people fight over stuff that doesn't matter because engineers do that. So this is an example like a V1 CDK app. I'm going to quickly synthesize this and then deploy it. So what I'm doing is I'm just changing into that directory. There's a Python virtual environment set up. I'm using Python for this. You can use C#, Java, Go, TypeScript, JavaScript. Python's what I use. Just because it reads better. It looks like human language more so than Java. No offense to anyone who does Java. And then say source. So this is just a generic Python command, activate the virtual environment. Python pip install. This should essentially do nothing because, yeah, I tested it earlier and the stuff's already there, but it's just saying pull all stuff out of the cache. And as it always does, it tells me my version of pip is out of date. But now I can do something like CDK synth. Oh yeah, I'm using an old version of Node. It does not like that at all. So if you only have a single CloudFormation stack, single CDK stack, when you do CDK synth, it will output it to the console. It'll always output it to, there's a directory called cdk.out on the left-hand side. And then it shows your template. I hit it up here, inside of here. So if you have like 10 stacks, it'll just make 10 different templates in there. Just the thing we do is like, if you're doing something simple with a single stack, we also print it to the standard out to the console so you can quickly see what you're doing. You don't have to go find that file, refresh it. I can't tell you the number of times I had that file open, I didn't realize it, and print a new version of that, but I wouldn't refresh the view. And it would be like, oh no, it's no change. And I kept making changes to the source, resynthesizing it, and nothing was changing because I wasn't refreshing the file. Like I said, this does the CDK synth, so you can look at the stack that's created. Here's the bucket, the S3 bucket, and then we set some non-default parameters. By default, we will set some properties on it, which is the deletion policy. If you delete the stack that contains this S3 bucket, we're going to retain the bucket by default, because if you make a mistake, it's better to have to like go in and delete something twice than to accidentally delete it once. All right, so the S3 service itself launched without that setting. So they, in CloudFormation, couldn't set that as a default value because it'd be a breaking change. So because we're using CDK, we can kind of reset the clock on what's a good best practice or a default value. Because we didn't know when we launched this, we didn't have to worry about best practices. Default value, we never worry about backwards compatibility best practices because we're launching something new. And now I will do a CDK deploy. And as I said, like that synth, you didn't have to do it, just the thing to show you kind of what you're about to do. And then I do CDK deploy. Oh, this is because I deployed it earlier when I was testing it, so I'm gonna make a small change. Not certain. I think that should replace it. And just to show that you don't have to do the synth, I'm going to do the CDK deploy. Now it's generating a change set, and it's deploying. So because I just deleted a bucket and recreated it, by default, CDK will prompt you for, if you make any change that changes your security posture, it'll prompt you to say, are you sure you want to do this? Here are the security changes. So if you are, adding additional IAM permissions, you're creating a new IAM role, the things that are changing your security posture, it'll prompt you and say, hey, do you want to make these changes? That's what it does by default. There's a flag you can pass to the the CLI command to tell it to not prompt you, which is useful in your your CI CD mechanisms where there isn't a person sitting at your build machine clicking yes. So you can say never require approval, but only in the CI mechanism. And we saw that just deployed and then it returned the stack arm to me. And to answer a question that you had earlier, so this is my bucket property. This thing that I get back is like the S3 bucket. That's the thing I can pass around in lieu of an ARN. And for things that expect an ARN, it'll know how to extract an ARN from that because it implements some kind of like high resource interface that ARN is a property of. There's kind of fancy software engineering craftsmanship that's gone on there. So if I wanted to like grant a Lambda function permission to write to a bucket, I could say like, check. Oh wait, I changed the path. I'll actually do it in a different. So that was CDK v1, CDK v2. This is strange, I should have. So now my path got messed up and it's not picking up these classes, my ID. But there'd be like a grant read, grant write thing, and it creates a S3 access policy, and you can pass in a Lambda function, and put in the ARN of the role attached to that function. And it's just like a method that's on there, so it would look something like so if we had some function defined, let's say like up here, a Lambda function that's how we would do that. There's no actual having to touch the ARN or reconstruct the ARN to build the policies.
My function is the Lambda object, right?
Yeah, it's actual, it's like,
Lambda.
yep, it's like what we did here when we created this S3 bucket.
Yep.
And here we see that we still have to import AWS Lambda and AWS S3. But if we go to our PY, we see that we only had to pull in the CDK library. So we didn't have to pull in separate dependencies for S3, for Lambda, for API Gateway, IAM, all these other things that we would use. Which in this example, we only have one or two things. It doesn't really make much sense. But if you get into a big, quote unquote, real application, you will see like savings in terms of not having to manage all those dependencies. So I'm going to cut it short there because we're right at like 7:15. And the people on the video can't really see that well. Does anyone have any questions? Sure, someone's got questions.
Take a question.
Sure.
So you mentioned like people writing test rid of stuff now that, as opposed to like when it was the declarative stuff, what kind of tests do you see people writing?
Unfortunately, what I see people writing a lot of is like, I think we might even have a test in here, but I think it doesn't even come with the test into that. I see people writing tests like, there's this capability where you can, like what we wrote here with a couple of S3 buckets, you can bundle that up as like an L2 or an L3 construct and vend that out to others. And you might have, say, if someone doesn't provide an encryption key, so where we see this, I think Liberty Mutual's talked about doing this publicly, so it's okay if I talk about them. What they do is they have like S3 buckets, but they've got like special Liberty Mutual buckets that they set the encryption key to a very specific value that guarantees that any bucket that they create will have, by default, will have that encryption key set for encryption at rest. So developers don't have to think about it. Developers could, if they really want to, go in and like change that, and they have other mechanisms to enforce that that is or isn't happening. But they would write tests to say, okay, use the construct without setting this property, and then do an assertion on the generated CloudFormation template to ensure that that KMS key property was set. And that's what we have, the assertions library that we just published makes it easier to do that. So it used to only be available in TypeScript, and then we made some changes to it to make it available in other languages, but you can do that same thing where you can say, okay, here's a CloudFormation template. Here's some CDK code and the CloudFormation template I expected to produce. So it's kind of like these like cucumber style tests, like domain driven design, where you can say, okay, here's my inputs and here's like the output. And then every time I run it, it would be cucumber. It's a golden test, right? You run it once and you generate like a template. You say, okay, I want it like no matter what code change someone makes, like this input needs to always produce this output. And you can check in those templates and use that as the test mechanism. You can use JUnit or PyTest or nose or whatever your test framework is for your language.
So are you then doing like a stint and then testing the output of that, I guess? Kind of?
Under the hood is doing something very similar to that. It's a full synth will actually like run through and it walks like there's actually like a tree, a CloudFormation template. You can think of it like a tree because it's the template, it's got resources, and then resources has a bunch of things inside of it. And like they might have child elements. We have constructs inside of them. A synth will like recursively check all of those. What it does in the test is that it just examines a single construct and expands out like just the parts of that. So it's like a mini synth.
Okay, makes sense.
And I think we have a couple of blog posts where people talk about how to test their code. Yes.
If I want to create an L3 construct and make it like a language agnostic, so I can have a Python version, a TypeScript version, a Go version, so what's the way to do it?
So you would write your construct in TypeScript, and then you would use the package we call JSII. And there's some extra data you add to package.json in your TypeScript package to augment that with the information it'll need for the other languages. So for Python, you need to know the distribution name and I forget what the other name is that Python uses in its package mechanism. For like a Java one, you need to know like the class path name or the class name. I forget the specific, it's how Java like handles dependencies. You basically need to say like, if someone's using your code in Java, like how will they refer to this bit of code is basically all you have to do. There's a bit like more nuance to it because even though it's TypeScript, we can only use a subset of TypeScript because we need to make sure that the code that's calling it in all these target languages doesn't have a conflict. So as we, did I do it in? Yeah, so here's an example of like, we're using Lambda in here, but it's just become like an idiom to like start with this underbar Lambda because the word Lambda is a reserved keyword in Python. So there's like things like that kind of pop up. So we have a list of words that you can't name your construct that you're exposing to people, the Lambda construct. You can't name it just the word Lambda by itself. Even though that might be valid in C# or might be valid in TypeScript where you do this and you plan on targeting writing TypeScript, it might be valid, targeting C# also valid, but because we need the ability to support Python, like it'll reject it because it doesn't comply with the reserved keywords. There's a tutorial I think I posted on the meetup page, everyone will be able to see it, right?
Yeah.
Okay, so I'll do that. So what I'll do is I'll post on the meetup page, like a tutorial for how to do like the JSI stuff, and I'll show an example of someone who did that.
Cool.
Yeah.
Any kind of simulator like SAM that uses, like you use SAM to simulate like the lamp function or the DB table?
They asked me if I did that, or,
It's CDK allow that.
you said we're not recording, right?
We are.
We are recording, so I have to be, okay. How do I put this? I need to think about how I say this so I don't get in trouble at work. So what CDK does, right, is it takes this representation. It's easy to think about. I mean, you can see it, keep recording now. But it's like kind of easy to reason about what's happening here. We're creating two buckets, right? Or we're creating a bucket, we're granting some read access to it. And it transforms this from like a people-friendly version to a CloudFormation-friendly version. And it does that locally on your machine through JSII and through the CDK. SAM does something very similar, but it does that in the cloud, right? So it takes a version of CloudFormation that's easier to reason about because it sets default values and it combines a bunch of resources into these kind of like L3-like resources. And then you give that to the CloudFormation service into this process called macros, which is a capability of CloudFormation. It'll do that same transformation. So what it's doing is it's transforming it from a version that's easy for humans to understand and putting it into a version that's compliant with the spec for CloudFormation. And because like in that regard, CDK and SAM are both doing the same thing. I don't see people using CDK and SAM together like that very frequently. Now, SAM is two things, right? Just like CloudFormation is two things and CDK is two things. SAM is the SAM CLI, which is the thing that runs locally, which is really cool. And then it's also the macro that runs in the cloud, which is also cool, but not as cool as the CLI. SAM CLI is nice because it allows you to run your Lambda functions locally and test them and invoke them, and you can connect them to these notional APIs and test this whole thing. So they have just announced the ability, it's in preview mode, where you can define your infrastructure in CDK and then use the SAM CLI to interact with it to test your functions. But it's not using the cloud-based SAM macro transform that people normally associate with SAM. Does that answer the question? I did that without making it look back, because the SAM team heard me say it. Yeah.
Somebody online asked, when will Ruby be supported?
Ruby is very popular, in the open roadmap, the public roadmap that we have, it shows like the languages that it's generally for like language support. It's the way we decide which ones get done first, basically whichever one's upvoted the most, like which ones has the most community support, is one we'll do. But there are some exceptions, so there are times where a language might not be as popular, but there's someone who's willing to do all the work. It takes about 2 engineers, about 6 months. If they really understand CDK and JSI and they really understand the language, 2 engineers, full-time work, 6 months, generally can create support for a language. If there is a team or there are people who really want to do that and they build that, we're not going to say, oh, no, this one's not popular, like, we're not going to accept this. So there are like capabilities for things to kind of skip the list, but I'd say Ruby, Rust, and PowerShell are like the 3 most popular that we're getting support today. So soon, I hope, but I can't really put a date on it.
Okay.
Thank you all again for having me. I have business cards over here if anyone needs those. Anyone has any other questions?
Anybody online have any other questions?
And I will put like the supplementary material, I'll post it on the meetup with the slide deck, and then some links to some of the sample content, especially for the people online, so they can see roughly what we did here, which wasn't super exciting.
Thanks, Richard.
Thanks for having me. I appreciate it.
All right, thanks, everybody. We'll have we'll meet up again next month. Again, no idea what we're gonna talk about yet, so if anybody wants to be a presenter, let me know. Otherwise, I'm trying to round up some people, so just keep an eye on the page and go from there.
Thank you.
Thank you.
All right, thanks, everybody.
You want me to hurry up and find someone to talk about certifications?
Yeah, that'd be great.
Okay. I mean, if no one from the group wants to talk, I can find someone who'll come in and talk to you guys.
All right,